Okay. All right. Am I streaming? Okay. All right, this is Dr. B, and we are here on October 31st. That's Halloween in the United States. So, kind of an interesting time here, kind of a day off in some ways. You still have to go to work, but then it's kind of a fun day too. I was curious about other countries. Do other countries celebrate Halloween? So, I actually looked it up and see if I can find it here. Here we go. So actually, lots of places celebrate Halloween. Mexico have a little different date here. All kinds of places. So if you're celebrating Halloween, I hope you're enjoying yourself there. But with chemistry, we don't really get a day off from studying, as you're probably aware. So tonight we're going to look at types of reactions. How do we classify chemical reactions into different types? Because you need to know that in order to predict what the products will be. So once you learn types, next thing you learn is predicting the products of reactions. So I think what we'll do tonight, a little bit different. I have these chemistry guides, and you may have seen some of them. I may have shared some with you before. I thought we'd kind of work through the chemistry guide and look a little bit at the strategy to learn how to figure out the types of reactions, do a little bit of practice, but then I'll give you the link for the guide as well, so you can have that to practice and study from. So let me jump over to the guide. Folks that are here, please say hello in the chat so I know who's around. I see there's a few folks. Wow, yep. Chun Li is here. Excellent. And Absolute Zero, of course. Leo, Amit, Loretta in Texas is here. Ongumbu, excellent. If you haven't said hi, say hello. It's always good to see some familiar faces and new names. Shivam is here as well. Good morning. It's actually evening here, Shivam, but so you must be on the other side of the world there. All right, so let's go over and look at the guide here. All right. So right now, this guide is a draft. I actually just created this yesterday and today. So it's still kind of in a draft form. So if you see any problems, note them and either tell me in the chat or my email's at the end of this form, which you'll have. Send me an email. Then I'll send you a nice email thanking you for finding an error. It looks like some more folks are here. Rakesh, Leonard, Cloudy, excellent. Idaho and India, kind of similar letter patterns. Awesome. Hey, Leo. All right. So types of reactions. You'll see this on lots of chemistry tests. The key to doing it is, if you're just learning about it, or maybe you already know, watch this video first on types of reactions. It's about 5 minutes, got lots of practice for you. And that may be all you need. So watch the video, and then down below, I have 20 practice problems for you. And we're going to look at some of them here. Northern Virginia, that's not far from me. So we're going to work through some of the practice problems. And when you do that, all the answers are here. So if you get it wrong, you can watch a video. Then make sure you understand what you're having problems with. Okay. So, and then we'll talk a little bit about some other types of reactions you might need to classify. One of the things you should understand is often we can classify a reaction as more than one type. So that kind of makes it a little bit confusing. And some of the reactions you're just not going to be able to classify, especially at the general chemistry level. So don't get too frustrated if you can't. All right, we've got, I'm not really doing too much organic assistance right now. That's kind of not my forte. I'm more an inorganic person. All right, someone from North Carolina or NC. Is that North Carolina? All right. So these are the types. I don't want to go through a bunch of notes though. That gets a little boring. So I'm just going to copy this right here. And then I'm going to paste it somewhere. Here it is. So let's just do first, see if you can find all of the combination reactions in this list here. So A plus B equals C is kind of the format, like iron plus sulfur gives you iron sulfide. So give that a try. Which ones are combination? A cat for Halloween, awesome. All right. All right, so two things coming into one. Trying to find some. Are there any? That's a combination reaction. These two things formed one thing. Combination 13 is, yep, in my mind, you're right. 13 is definitely a combination reaction. Two things come into one. Is that all that we have here? One more. Right here. That's a combination as well. All right. So you might wonder, when you look at this one right here, let me come in real big. How do you know that you can have Ca3N2? I mean, you have Ca and N2. How do you know? The thing is, if you know your ionic charge, calcium's 2 plus, then nitrogen's always going to be 3 minus. And you could use a crisscross method, move the 3, if you can, move the 3 down here, and then we move the 2 so the charge is balanced. We don't worry about the actual charge at that point. We just get rid of that. So that's why it's Ca3N2, because the charge is balanced. A lot of people have concerns about that. All right. And combination is also called synthesis. You are right, Jason. All right, so we got those. Let's see if we can look at some other ones. There's a lot of activity in the chat between Leo and Ongombo about cats. I'm not sure what's going on. All right, so decomposition. I almost don't even need to put this down here. You should be able to see the decomposition's pretty easy. So which ones are decomposing? Breaking apart. One thing breaks into two, or it could break into more different things. What is breaking apart? Not seeing many. Okay, I see one. I think I only see one. Thank you, DTP. That's appreciated. I've been on YouTube a long time. Here's the only one I'm seeing, unless somebody else sees another decomposition. And this one is breaking into three things. So sometimes is 17? Oh, 17 is a decomposition. You're right. I circled it as a synthesis. I'm wrong. It's a decomposition. Two things. The one thing broke into two. So I was wrong about that. That's not synthesis. That's decomposition. Thank you, Absolute Zero, for setting me straight. All right, let's do some single displacement reactions. And then I'll show you a demo that it's not super exciting, but it's okay. All right. So see if you can find the single displacement. And you're always going to have something by itself, like Cl2, or a metal like Fe, and then a combination. And these two things here, one will push the other one out. That's your single displacement. Blue Ink asks if is organic chemistry hard? It's a lot more memorization. Oh, let me move that there too. How about that? There's a lot more memorization in organic chemistry. Very little math. Very little math. Thank you, Absolute Zero. I removed the little picture of me there. All right. So single displacement, that's what we want to find here. Looks like number one, yep, Ridgel, you got it right. Number one, the zinc pushes the silver out. So this is a single displacement. Sometimes teachers write SR. I don't know. What else? That? No. What else are we seeing? 5, I would agree that 5 is single displacement because the chlorine this time, oops, the chlorine pushes the bromine out and the bromine's by itself. 7, yeah, that's single displacement, single replacement or single displacement because the Mg pushes out the hydrogen. Is 9, there's a lot of single replacement. Teachers like to give you these type of problems. 14, yep, and 19. So lots of single replacement reactions. So let me show you this one right here, this FeCOSO4, the iron and the copper 2 sulfate, where the iron pushes the copper out. So I'm going to pull my camera down here. Let's see if I can put it right on these things here. There we go. All right, let me switch over to my big camera here. Make you all dizzy here. All right. This is actually harder than it looks. I'm going to get 2 cameras. So the blue right here, this is copper 2 sulfate. And what I'm going to do is I'll put a nail, this nice shiny nail, in with the copper 2 sulfate. And the copper is going to be replaced by the iron. So bits of the nail will come off into our copper 2 sulfate, and then the iron will dissolve a little bit. See if that happens. You can already see that there's iron on the nail there. If I can get out of the shadow, you can already see the copper coming out onto the nail, like instantly happens. Let's put it there. If you wait a long time, like 2 hours, this is what you end up with. Right here. See that fuzzy thing? Now, it doesn't become green, actually, Ridgel. It actually, the color goes away. And I'll show you why in a minute. Watch what happens when I bang this. All the stuff will come off the, all the copper will fall off. And now you can see the nail there. It was just covered in the copper that's now at the bottom of the test tube. So that's an example of a single replacement reaction. Let me show you what it looks like here in the chemistry. It's just so you understand this single replacement really well. So we have our iron, that's our nail, and we add our copper sulfate, that's the blue solution. And the copper is what's making it blue. So when the iron pushes the copper out, you end up with copper all by itself, plus the iron sulfate. So this is your single replacement. We didn't have any solid copper starting out, but when we were done, we had that all there at the bottom. Eventually, basically what happens, Cloudy, is that what happens is that once that blue is gone, the reaction stops. There's just no more reaction. Once all the iron here is iron sulfate, or all the copper is copper sulfate goes to solid copper, the reaction just stops. All right. Let's go back, and it's getting to a little bit. We'll do a little bit more here, and then I'll give you the link for that there so you can have the guide and use it. Yeah, you can do it a penny in zinc, but the zinc probably would be put in hydrochloric acid, or I should say nitric acid, because copper doesn't dissolve real well. You'd have to use like nitric acid, and it's a pretty cool reaction. All right, so let's do some double displacement reactions here. FeSO4 is probably not green. Usually your nickels or your coppers are blue. Coppers can be green too. FeSO4 is just like a clear solution. You don't see anything. FeCl3 is kind of a red, reddish, dark red. Yeah, I have some of it somewhere here. All right. Thank you, Leo. And let's see. Why don't we do combustion reactions next? Because that's really easy. Whenever you have like a hydrocarbon, something with hydrogen and carbon here, and you add oxygen and you get carbon dioxide and water, that's going to be combustion. Yeah, absolutely. You're right. CuCl2. That's what you were thinking of. That is correct. So if you look here, you should be quickly able to find all the combustion reactions because they're all going to end. They're all going to have this here. So there's one. Are there any more? 11, yeah, 11, that's combustion. I think there's one more. 15, even though there's oxygen in it, it's still combustion because you have all of these right here. Yep, 15. Combustion. I think that's it. So 2's a combustion, 11, 15, and 18 would be combustion as well, because we have our oxygen, carbon dioxide, and water. So those are the ones. So if you know those, that's pretty much it for combustion. You don't have to worry about that too much more. The other ones that we have here, talking about the double displacement, that's kind of what's left now, right? It's the double displacement. So we don't really have to go through all of that. But you can see that with double displacement, they just switch places. So where's another one? Here's one. PB and the K, they just switch places. That's your double displacement. Yeah. 20 is a bit of a weird one. And if you look at the guide, I think it may talk about that. All right. So I just want to show you a few more things. So if you want to go back and do these afterwards, you can check the answers, and that would really lock this into your memory. There are a few other types of reactions that may be really useful for you to know. One is that if you have an acid and a base, you'll get a salt and a water, and that's called neutralization, but it's just a double displacement reaction. It's just a special type of one. You also get what's called a precipitation reaction, and that's when you have a solid forming. So it's a double displacement, but it forms a solid. And most of these reactions you'll see when you look at double displacement, they're going to be this type here where it forms a precipitate. You should also know about these endothermic and exothermic reactions, which you probably do, but what I'd like to alert you to is that combustion reactions and neutralization, they're going to be exothermic. Decomposition is going to be endothermic. So that's a good rule of thumb. That's real useful to know. And there's some practice here you could do if you wanted later with the guide. Other than that, we got redox. If you want to know about redox, there's some information here. One thing you should know, though, is that displacement and combustion reactions, single displacement and combustion, they're almost always going to be redox. But neutralization and double displacement are very rarely redox. So I think that's it. I think that I'm going to drop this into chat here. I'll drop this guy into chat here so you can get the guide. Where is it at? You can get the guide here and have it for your notes. If you find any errors, email me. Tell me about them, and I'll fix them. See you later, Deep DP. You got to go to school. Yeah, it's morning there, right? All right. And I'm going to jump over onto Discord. You are welcome to join me there. We'll kind of just chat a little bit about what we did in the stream. Let me put the link in there for my Discord server, and I'll jump over there. There it is. And I think that's it. Thank you, everyone, for being here this evening. I do appreciate it. You know, it's Halloween. You could have been out collecting candy and dressing up as different characters. I will be back on Thursday, and I'll have hopefully a guide for predicting chemical reactions, how you do that, predicting the products. And that's something that students really have a big difficulty with. So hopefully it can help you through that. All right, everybody, this is Dr. B. And as always, thanks for watching. I'll see you on Discord if you're that way, or next Thursday.